we will continue class and method design. I said this chapter is quite difficult, so please pay attention on our discussion. Last time we reviewed inheritance conflicts. And we talk about coupling, all right, and we know that this chapter will cover coupling, cohesion, connaissance, and refactoring, optimizations, etc. Right. They're related to method and class design, right? So whenever we talk about the code, it becomes very difficult. And to write a code, not just write the code. You need to have logical reasoning. You should know why the code is written like that, but not the other, right? So we're not going to just make the function go, but how can it perform better, right? Or later on, it will be easy to maintain. But we can reuse that, so we need to concern the quality. Right? So that's why this chapter become very important. Right. So when we talk about coupling, right? So why this issue is important? We wanted to reduce it, right? Reduce the relationship, and we know that relationship is very important, right? So it seems contradict, right? One way we said that function will not stand alone, and a class should not be so powerful, right? Should share part of the responsibility to others. But the other way we said that we need to reduce coupling. So that means that not too extreme, right? So what is better, right? Don't go to the extreme. No coupling. Actually, it will not exist, right? No coupling. This is no coupling. No such a system exists, which is modelless. No, we have some kind or some level of coupling. It depends on the situation, right? If we care about performance, then probably, we are going to compact it. So that would relate it to the issue of cohesion, right? So when we think about coupling, then it is an interrelationship between methods or classes. Right? Go beyond yourself, or go beyond one component, because method talk to method, even it is within one component, but also it's interaction, like your body, right? So each part is not standalone. They have signal from others. They should cooperate with each other. That become a system, right? So we talk about coupling. It doesn't mean that no coupling is the best one, right? So it depends on the situation. Some condition, we should couple with others, right? If that brings more benefits, then we will adopt that. So you have a choice, and you have reason to support your design, right? If you focus on maintenance, then that's the coupling and increase cohesion. All right, increase cohesion. Then we look intra. So one component. If a class contains the thing that's highly related to the class should know and perform. And we said that high coherence stickers, high coherent, because they talk about the class should know and should perform. So high coherence. But what about should? The word should, right? It says the less, the better. Well, not necessary, right? So we say it's high coherence. It's a high coherence, right? With high coherent situation, cohesive, or a high cohesion of it, even a method towards a method, because class and method design, right? A method, we talk about coupling, yes. Method can talk with other method, but look at the method itself. We can look at its cohesion, right? Well, the method perform one and only one single task. Now we said, well, we know that this method can be reused, and we from the naming, we know the method does the thing, right? And without a combination with others, it's very high cohesion. It is coherent. But today we still need to look at different type, different levels of cohesion, right? So it exists. Whenever you need it, you use it. Should have a reason, right? But you should know that higher the cohesion, then it's easy to maintain, right? So we have like a scale, right? Now go to the string, and coupling and cohesion usually stands at different ends. We raise the cohesion, or sometimes no, we lower the coupling. Or we lower the coupling and you raise the cohesion. But it is not always like that. Sometimes it can raise cohesion and coupling. Right. So then we look at that. Alright. So we have finished coupling, right? And let's see cohesion. So I said cohesion, how stick it, close together. So look at a method cohesion, right? So look at method. So method itself. Does the method conduct one single task? Then it is highly coherent, right? So method cohesion, does the method perform more than one operation? If that's so, well, it is not, what we call is high cohesion. But sometimes we just need it, right? So yeah, method cohesion, so there's a scale of levels. Performing more than one operation is more difficult to understand and implement, right? But, well, this is not exactly the truth, right? So it depends. So sometimes when we combine the two operations together, even though it's lower, it has lower cohesion, right? Low cohesion than only one function. But whenever it is necessary, then we do that because that would be better than isolate them, all right? But just the difference of the level. Class cohesion, right? So we look at class. Class has many method and variable, all right? So look at the class. Does the class perform all the related thing to the class? Then that's high cohesion. So we jump out the method itself, right, and look at the class. How do we design the class inside the class, probably a couple function, couple method, then we group that together because they perform better than isolated method. Then look at the class cohesion. Well, that's a good design, right? And also here we can see generalization, specialization, cohesion. So coupling also has this kinds, inheritance coupling, right? So the cohesion also, generalization, specialization, cohesion. Okay. So like this, we said this, the example about this one, the low cohesion compared to the lower part is high cohesion. We know that it's staff, right? Staff can check mail, right? As check mail, send mail, and here only to validate email and then print it. We know that's the different task. Only to print it, it's different from the check mail, right? And the lower part, the same. So the design, we give the information that the staff should know the salary and know the email address, right? So when we get and set the salary, and then we notify the staff, right? Or talk about the same thing, right? So we set and get it, email. Then it's better, it's better to notify staff. So we put it together, become high cohesion within the staff. So you need to have reason to justify your design, all right? I think that, well, it's quite natural to do that. Or here, cohesion, right? Connection poor. So here you can see that connection poor, know something, right? But here you can see that there's some calculation, statistic, right? And the connection and statistic, we put this all together. You should have a reason, to describe that. Otherwise, well, that's hard to maintain because connection poor, right? So this one probably wanted to reuse the connection, this part. But whenever you wanted to reuse it, you still need to have all this. Whenever you have inheritance, right, you inherit everything. So the subclass inherit everything from the superclass. But if the superclass is not coherent, of course, the lower, right, the subclass have everything. Also, that's not coherent at all. So from the parents, then we make some correction, or it is not generalization, specialization. Anyhow, we separate that, right? We group something that are sticky together as a class. So then we separate them, right? So part of that is the statistic, and the other is about here is the store, right? The persistence is the data store. Separate them. That would be better to reuse each part. Yep. Okay, so you see this. And this one, we know that these two classes, all right, has some method. They are the same, all right. So we upload it. So we create an interface. So since probably more than these two classes will use these two, they can reuse it. So we create an interface, right, with these two methods because it's going to be shared by more than two probably, right? So we do this. Then it says low coupling. So connection statistic, we isolate it, we take it out, right, and becomes a class relies on connection listener. this one relies on X, right? And it will not mix with other method, right? Like if connection poor has a lot of things, then we know that if one class has a lot of method, and then other would look upon it like fencing, because this class has a lot of method, right? Then other need to ask toward the same targets. It's fencing. Since it's a fencing, then it's a lot of coupling, so we lower the coupling. Some will rely on store and go to it, and the other, so we separate the connection. All right. It means that we can refactor, right? So it's a concept of refactor. Okay. Types of method cohesion. So we have method cohesion and class cohesion. Method, from good to bad, right? Functional cohesion, because we look at the method perform only one task, is functional, right? But sometimes we think that, well, it could be better. I said it could be better to link two methods together, right? Because we have a reason. The reason is the output from the first method become the inputs of the second method. It makes sense, right? So we don't separate them. And we take from the first processing and give it to the next one. Probably the next one, and to the next, and to the next. Since they are highly related about each outputs, then we link it together. We call it screenshot because that is an order from previous one, pass the result to the later one. Right? Not just one pair, probably not just one pair, and then passes to the next and to the next. Then we can group it together. So you have a reason to justify that. All right, that is better than only we put all function, So, but of course, that's less reusable than the first one function. If some component need to use only piece of that, then that's a problem, right? So, yeah. Regarding the levels of cohesion, then we know that the first one, only one function, of course, that's better than the second one. Sequential, right? And communication, right? We conduct something based on one variable, right? And this variable, we access that is for our computation, right? So that's communication. So whenever that one change, they will affect the others. The same, sequential. Whenever previous one change, they will affect the other, right? So I said that affect the other. This kind of change is coexist. So actually, I'm talking the concept of connaissance. Connaissance means, something they coexist. Whenever you change one, they will affect the others. So it's a kind of connaissance. Also, when we balance coupling and cohesion, that is also connaissance. You change one part, coupling, then it will affect cohesion, right? So it's connaissance. We look at the thing, together. Probably we change the position, they will change that. So whenever the change affects the other dependents, it's a kind of connaissance. Right. So that means that, don't change anything randomly. You need to have a reason to support it, right? Or think about someone relies on you, right? So you change this, it will affect the others. Procedure, everybody knows that. So procedure, well, it's just not like sequential, right? Procedure, we put a lot of things, they may not highly related, right? But so for somehow, this belong to the task. So when we talk about there only one, it's a piece of it, right? So here, when we conduct something, then it relies on other method, right? So jump out to other method. And also this related to synchronize, asynchronous. So lots of the thing, right, are highly related. And temporal, that means the time. Well, it will not happen, no. All the method, not like that, but no. Sometimes, no, we need the time. We also know that time is an actor, right? We need the time to remind us or remind the system to do something that we want to maintain it. So when time's up, reach the point of the time, some function, no, maybe they are not related. We hope that they can be activated. So it's a temporal, right? Temporal. So in the time, we cannot manipulate the time. If we set the time, then we need to obey that. To follow that, you cannot say stop that for a second. No way, because just tickling. There's a time, and logical, right? Usually, we will see that some tests, they seems related, but actually they perform different tasks. It seems logical, right? To put that, probably you wanted to put that together, like here, the description says the banking system, right? Banking, you have checking account, but checking account it has different interest from saving account, and the meaning will be different from long accounts, right? Checking account, we deposit to a checking account, but checking account provides flexibility. We can withdraw at anytime because lower interest, right? But a saving account give you higher interest, but there's a limitation, like a certificate, right? Certificate deposit, we call it CD, right? So probably 6 months, depends on what you need. You are not going to withdraw that. If you want to, then you will deduct the interest, right? So there's a difference. And a loan, you wanted to borrow money from the bank, so that's different, all right? So the loan you owe to the bank, that's different. But like last time when we talk about salary, right? So when you compute salary or compute pay, I should say compute pay, there's an employee or a customer, it's a difference, right? So the year we put, it seems not similar thing, but look like similar. We put it together, that's logical, right? So logical, if we need to reuse checking accounts, well, you buy a lot of things together. That's not good at all. All right, separate them. And the last one is coincidental. Of course, that's the worst one, like contents. It says content coupling. You wanted to manipulate the class operation or set the value like that. This coincidental, it means I don't know how to deal with that, but whatever, we'll put it together. Not like a logical, at least it seems logical, right? The account, right? Different kinds of accounts. We put it together, they're logical, but it's coincidental. It's all the maths, you put it all together. So it's not coherent, of course, not all the bits. So that is the matter of cohesion, right? So I gave you the example and you just check it out. And here, I want to give an example. Alright, so this example is going to have the situation that when we talk about inheritance conflicts, right? One of that is multiple inheritance, right? So if you have a situation that has come from different programming language, support multiple inheritance, right? Then you should change that. Based on the situation, change that. So now, it gives you the multiple inheritance the situation. How can we, change them, make it better? So maybe that's. What do I give this? Okay. We have duck. All right. And duck is many, many kinds of duck. All right. So suppose that we have a duck, meret, like meret with green hat, meret, MARALD, or Peking dark. So different kinds of duck. It's a kind of duck. Like, right? Can you see that's the back? So whatever, any kind of duck is a Peking duck, right? And also, well, some programming language support multiple inheritance. So here, but you wanted to change the problem domain to object-related, it's object-oriented, but cannot support multiple inheritance. How can we change that? We wanted to change the design. How can we change that? So we want to change it to the same object-oriented, but it's only single inheritance. How can we change it? Wes, do you understand this? Yes or no? How can we change that from multiple inheritance to single inheritance? It is. Raise your hand, you understand that? From multiple inheritance to single inheritance. Ethan, do you understand that? How to change that? Jeffrey? Oh, oh. None of us. What about you guys? From multiple inheritance to single inheritance. Howard, do you understand that? Oh. Harry, how to change that? Nobody knows that? Kara? I think that's not difficult at all.
I think the Peking duck don't extend bird.
Okay.
Mm.
So you wanted to change.
I think duck is a kind of bird, so the duck can inherit the bird,
Mm-hmm. Oh.
and the Peking duck inherit the duck.
So okay, is that you wanted to change, become this, and take it out.
Yes.
So it means that if dog is a bird, right? Dog is a bird. Peking duck is a duck. Since the inheritance, we change this. So it means that Peking duck also, inherit from duck, and we change bird will affect everyone, right? If we change bird, will the change affect Peking duck? Yes or no? Yes. Okay. So you will need to change become this, but yeah, you can change the dads to become single inheritance. On the other hand, we said that this kind of design, we densen the inheritance from one level to two levels. All right. Any other change? Yes, it's a kind of change from multiple inheritance to single inheritance, but we can do another way. Yeah, we can do this. What else? Harry?
Scatters is like dog inheritance bird, but dog the prone dog is aggregation with cock. Is to change the protein guard and dog in the relationship is aggregation.
Aggregation?
Yep.
So here, you want it, say it again.
Is inheritance.
Inheritance?
Yes.
And then?
And dog and protein guard is aggregation.
Dog and Peking duck is aggregation?
Yes.
How come Peking duck is a part of duck? It's a kind of duck. It's not part. Right, which part? Wing, body, head. It's not part, not part whole, right? So the first one, that I accept this, but the second, no, it's not. So what else you can, modify this from multiple inheritance to single inheritance. Okay,
Maybe we can change bird to interface and the duck and pinky duck to can implement the bird interface.
Okay. So if that's bird becoming interface, then is a duck implemented?
Yes.
Take out it.
Yes.
So since duck implements bird, that means Peking duck is also implemented, right?
Yes.
Yeah, it's a similar to this, right? So we just change it, become an interface, right? And it's a two level, right? Yes. You can do that. You can do that. It's implementation, but now I said that we need to change the problem domain. So that is the original one, right? Original one that a Peking duck inherit from bird, and Peking duck inherit from duck. All right. So the green one that meets the problem domain because yeah, bird become an interface, right? But the previous one, bird is not an interface. You can change this, but this one will be better than because it changed from class to interface. Okay. And what else? When you change the relationship from multiple inheritance to single inheritance. Okay, then you can tell them, right? Association, which one? Become association. All right, and we take out this because we don't like multiple inheritance. All right. And what about this part? We don't need that. That's better. This one is better. So the province domain, no. Duck. So pig and duck inherit from duck. And then pig and duck. Because the multiple inheritance, inherit from bird. We do support multiple inheritance, the concept, because multiple inheritance is a lot of problem, right? So we don't like that, so we choose one. It seems that pig and duck inherit from duck, well, it's better, right? Pig and duck is a kind of duck. It's quite close than bird, right? Because bird, it's different kind. So a lot of things we saw this bird. So we change it become association. It's better. Okay, association. And okay, so now let's change that. Okay, this. So yeah, you can change like duck is a bird. It's a kind of bird, right? You can do that, but that becomes two levels of inheritance. Then we can change, become this. All right. And then the thing about that, so we change the structure. What about the multiplicity? Multiplicity, the number. The number, multiplicity. What's the multiplicity? Peking duck? Yeah. Or bird toward a Peking duck. So this. Now we are going to change it from inheritance to association. All right. To get rid of this, if we only look at association, not inheritance. Right. So A and B. Association. Right. So it could be one to one. One to many, many to one. That's. So how can we look at that? Kevin.
I think it's one too many.
Which one is one too many?
Bird is one and Peking duck is many.
Is it many?
Yes,
As one.
yes.
Okay, would you explain it? So here, one, right? And this is many.
Yes.
Would you explain?
And,
Bird.
I think bird is kind of class and the Peking duck can have
Bird
many.
is a kind of
应该说一
Peking
种
duck.
类型的物种，a type of animal. So the type of animal can have many Peking duck.
Can have many Peking duck,
Yes,
and then Peking duck
Peking duck has one bird,
belong to
one bird.
a bird.
Yes.
I know what you mean. And so now, ask you that. We know that cars could be abstract or concrete. What about a bird could be abstract or concrete? Right. What bit of difference?
I think it's abstract.
I said could be, right? So when birds are abstract, would be the same. The concrete will be the same.
I think it's not the same.
Not the same. Tell me. What do you mean?
Abstract is the top of the. I think if it is concrete and it will be one to one, and if it is abstract, it will one to many.
If it's abstract, here it's a one-to-one.
Yeah, no, concrete is one to one, and the abstract
Concrete
is
is, so concrete, here's a one and here's a one.
yes.
If it's abstract, it's many. No. Would you explain it? So it's a one and many. Many means zero dot star, right?
Oh.
The one means one dot one, right? So means one, right? Only one. There's a one dot one. It's a two situation. Is that if it's a concrete, it's abstract. Why? What do you mean that? So that's. And tell us. That. Would you explain it?
I think one abstract class can have many of the class.
It doesn't make sense because it's abstract. It has many. Hank, can you explain this? Do you understand this? It's the second time we take this course. Bus, do you understand this? Second time. We take this course, right? Chen. How we cannot follow since last week, you know? You don't have a clue. What about you guys? You got no idea about that. No, no, sir. You know that, right? You guys know that? Know that? What? Okay, here, a relationship, right? Because from inheritance to relationship, it was the parent, right? And become friend, right? It was the parents become friends. It was the child also become friends because only have one parents, the single parents, right? So here, it could be abstract, could be concrete. When it is abstract, that means if it is abstract, then Kathy, if here bird is an abstract class, can bird instantiate itself? Instantiate itself. Can you a bird? If bird is abstract, can bird knew a bird? Scrolling. If bird is abstract, can bird instantiate itself? No. Right. So if bird is abstract, cannot instantiate itself. So this relationship, we need to have one. Because abstract the abstract and abstract cannot instantiate itself. So the relationship need to have one. It's concrete. It's concrete. It was the parent can instantiate itself. So 0, 1. It can instantiate itself. It become 0, 1. It was a parent. Parent and children, you cannot change that. It's always 1 and 1. Right. The year is 1. It's 1. All right. Big and dark is 1. All right. 1 and only 1. And yeah, if it's abstract cannot instantiate itself. So you need to have 1. If it's concrete, it can instantiate itself. So it could be 0 or 1. 1 is okay, or 0. Okay. Birds need to know, need to have ducking. The Peking duck. And Peking duck also knows friend. Need to know Peking duck. So become this. Now if the previous problem domain, right, not that easy. And also it's a Marat. Right. And Meret, right? So green hats is a kind. Green head duck. Meret is a kind of green head duck. And since previous domain support multiple inheritance, also you can see this. Don't give me this. It's a private design, you know. You know, that was the previous design. So based on what I just described, the left hand side, and then change the right hand side. Can you get it? Okay, tell me that.
So it means like a Peking duck is here in the duck and the domain of the Peking duck is show like a asteroid in the class, and it will maybe a abstract or a concrete abstract of
No,
concrete.
I give you the example, then
Yes.
change the right hand side here. How to change that? Now we have another multiple inheritance. Change that. Change.
Change.
Yeah.
So
So what?
so change the bird inheriment to the aggregation.
Aggregation?
Yeah.
Aggregation? So Meret is a part of bird, right? Look at the head, but wing. Aggregation. Part whole. It's just that I follow the left side. What's wrong
Yeah.
with it? What's wrong with my, description? What? Change. Okay, change. So change that from inheritance to